exercise 54, question number 3. This is a required question, so I'm going to do one that's exactly like it, and then after you've had a go at that, you could try the question in the textbook. So this indicial equation can be solved using logarithms. It is an indicial equation because the x is in the power. So first step, take the logarithm of both sides. So logarithm of 4 to the power 2x minus 4 equals the logarithm of 5 to the power x plus 1. Which means that the power can come down and multiply. So this means that 2x minus 4 times logarithm of 4. Note the bracket is important because I'm multiplying the logarithm of 4 by the whole of that power, 2x minus 4, equals x plus 1, again in brackets, times the logarithm of 5. And if you're going to take the logarithm of both sides, you could just jump straight to this step. Because by taking the logarithm, that means the power comes down and becomes a multiplier. So I can go straight to this line. Now at this point, I could expand out the brackets and multiply 2x by log 4. And then minus 4 by log 4. And then on the other side, x times log 5 plus 1 times log 5. That will work, but it's quite long-winded. What I always do in these cases is think, I'll try and make life easy for myself. So if I divide both sides by log 4, then I'm going to get something on the right-hand side that's easy to multiply out. X plus 1 times that answer is much easier to work out than 2x minus 4 times something. So divide both sides by log 4, and I get 2x minus 4 equals x plus 1 times log 5 over log 4. Now I can work out what log 5 over log 4 is, which will just be a number, and then I can multiply out that bracket. So 2x minus 4 equals x plus 1 times, what's log 5 divided by log 4 in a calculator? 1.16 to 3 significant figures. So now multiply out the brackets. 2x minus 4 equals 1.16 times x plus 1.16 times 1, which is 1.16. So that's an easy expansion to do. It would have been more difficult to expand out a number into the left-hand side, 2x minus 4. Now I've got x on both sides of the equation. So this is an equation to solve. I will take the 1.16x away from both sides to leave just x's on the left-hand side. And then I would add 4 to both sides to get the numbers on the right-hand side. So, subtracting 1.16 from both sides, I get 0.84 x minus 4 equals 1.16. And then adding 4 to both sides to get rid of the minus 4 on the left, I get 0.84x equals 1.16 plus 4. So 0.84x equals 5.16. Now divide both sides by 0.84 and I get x equals 5.16 divided by 0.84. And now I can work out what that is, and that's x. And check it works by putting x back into the original equation to see if it works. Always a good idea. So, see if you can finish that off, and then the answer will follow, and then you can have a go at the question in the exercise. So, looking at the solution, I get x equals 6.143 to 4 significant figures. Putting this back into the equation, I get 4 to the 2x minus 4. Let's work out what the left-hand side is. that turns out to be 4 to the 8.286, which gives me 97,424.7. And then putting it into the right hand side, 5 to the x plus 1, what's 5 to the 7.143? 98,342.8. Note they're not the same. And that's a rounding issue. When I rounded my value of x originally on the first sheet to get 1.16 or x 5.16 over 9.84, there's lots of rounding going on in here. First of all, I rounded the answer to log 5 divided by log 4 to get 1.16. I gave that to 3 significant figures. And then I divided 5.16 by 0.84, and that too was a rounded answer to 4 significant figures. So I'm rounding, and note the difference in the answers. And the reason is because x is in the power, so that makes a big difference. A small change in x means a big difference in the answer if we're talking about powers. So you have to be careful of that and try and hang on to as many significant figures as possible throughout the solution. Now have a go at that one in the exercise required question.